Hello guys, I'm back. This is a follow-up to the last video I did to answer a couple questions. And one of them I meant to have in the other video, and I forgot to put it in there. Should script my videos, I guess. Or at least put notes down. A question was asked about why is the primary coil on this bobbin inside the coil form, and I wanted to actually talk about that, and I didn't get a chance, so I'm glad the question was asked. There's actually to a certain extent a couple reasons for that, why they did that. One has to do with the fact the type of radio it is. These radios, TRF radios, tuned radio frequency radios, by their nature of how they operate, where you've got several stages of amplification that is tuned, are really bad about regeneration or feedback and causing oscillation. So they heavily shield them, but a lot of times that's not enough, just shielding, to keep that from happening. So sometimes you have to use some other means of doing that. And one of those means is to take your coils and try to do something with them that will allow them not to be able to, even with the shielding, affect other stages, as the well, basically as the magnetic field that they produce is build up and expanding and contracting. Now, on some radios, and you will find some of these, one of the things that they would do is something of this nature. If this was, well, I can use this. This being your coil, let's say this is one of your coils. What they would do is they would take one stage and set the coil like this. And then take another stage and set a coil like this. And then they would do, basically 90 degrees to each other. And then another coil would be set like this one, like this coil of solder. In other words, straight up and down like this. And what the idea of that is you're keeping the magnetic field or the coils 90 degrees to each other. So the magnetic field is strongest and is produced going in this direction. So it will flow out this way and this way, being produced, the flux lines coming out one end and coming back in the other end, and that would expand this way. If the two coils were side by side like this, then you get the maximum mutual inductance, or the maximum influence. But if they're 90 degrees to each other, then you have a lot less of this magnetic field able to cut across these windings. So it's a lot weaker. So they would do, some manufacturers would set their coils up so that they're 90 degrees to each other. Other manufacturers did other tricks, and one of the tricks was to do this. The biggest magnetic flux is going to be created on the plate of the tube. That's where your strongest signal is, because it's an amplifier tube. It's an amplified signal. Well, that's what these coils inside the primaries go to. So they're actually set at 90 degrees to all the coils, as you see inside. And they put them inside also on these. If you wound it on the outside, well, it'd be kind of hard to do, but on the outside, then it would be parallel with this coil here, which would be parallel with the rest of them. You could mount it on the outside, but then the secondary is acting also as a shield with it inside, so it don't have that shield, and also it's not going to be able to cut as much of these wires as it would if it's on the inside. So being on the inside, it's shielded by its own secondary, but also it's given the chance to cut the most number of wires as the field builds up inside here. But one of the big things about it being 90 degrees turned the way it is so it doesn't affect the other coils that are in here, or less likely. We still had to shield them. They got shield cans on them, but it reduces the amount of the possibility of regeneration or feedback causing oscillation. And that's another reason why these 4, I have seen them with 5 stages of amplification. Generally 3 and 4 is the standard. 4 getting to the upper end, 5 being really pushing it, and you have to really shield things. The other thing about doing this, the second reason for doing this, is this particular tube, number 24A or type 24As that's in here, that they use in these, really they're biased at a -3 volts. That's their pretty much their standard bias for the grids. These tubes will not and do not like going in saturation. They don't want the grids going positive. So when you amplify the signal and it goes through and goes to the grid in the next stage, you want to keep that signal so it's not swinging above that 3 volts. In other words, the positive swing will not take the grid positive. So you want to keep it within a peak to peak of maximum of 3 volts. So by doing setting these coils also at 90 degrees inside, it's making a coupling that's extremely loose, so that these I don't cut as much of the strength is not as strong on my magnetic field that I'm cutting across these wires on the secondary, so I keep my voltage fairly low. It's amplified, but it's really low. You got to realize it is amplified. The incoming signal coming on the antenna on any radio, the signal you pick up out of the air is in the microvolts. It's extremely weak. So we are amplifying as we go through, but we're keeping it within a limit by doing this. This also keeps the gain into a limit so that I don't get such a high gain, especially by the time I get to the final amp, that I cause any type of feedback or regeneration and consequently squealing. Now, I hope that kind of answers it. If there's any other questions on that, why they're done that way, I'll do a video strictly on how these things work, why there is the potential feedback and so forth. The other question was why didn't I rewind the primary on this transformer? And really one of the primary reasons why I didn't was I've got a good operational secondary. The primary on any transformer is the deepest winding. It's the first winding on the form, so that would mean in order for me to rewind it, I would have had unwound and take off the secondary that is good and operational to even get to the primary. And the enamel on these wires is 85 years old. It's very brittle. If I was to do that, I would pretty much have to discard that secondary and put new wires on. So, and the other thing too is for me to get this back tightly wound and put back into this form, and also try to duplicate this paper, because you're not going to get the paper off in one tack. This is coated with enamel too, or shellac at least, the very least. It's glued on. It would just be in pieces. It was going to be a lot more trouble than needed, and it would be a complete rewinding of the entire transformer, and it probably definitely not be, it definitely would not look the same. So I just chose not to mess with it. Now if the secondary was also gone or something, and I so chose to actually rewind it, maybe I couldn't find a transformer, or if it was the secondary that was out, that might have been a slightly different story. But it was the primary, and the primary on any transformer is the deepest winding. So that's why I chose not to rewind it and mess with it. I think that pretty much answers those two questions, and again, if there's any further interests or questions on shielding and how we take care of trying to keep any type of feedback from happening by adjustment of the coils and how we change the coils and everything, then you know, how we orient them and stuff, I can do another video on that. So this is kind of short video. I just wanted to answer those two questions on that, and thank you guys for your comments and stuff, and so I guess I'll see you on the next video. Thanks.